Hello everyone, in today's lecture we will discuss about the extended operator. Now students, the invariance of linear first order ordinary differential equation leads to the equation number 2.84, and this is actually the least invariance condition. Now students, we want to introduce an infinitesimal operator in 2.83. Now we introduce the extended operator. As you know that we have already defined the infinitesimal operator by something like this. Now we want to find the value of gamma 1. Now gamma 1 is equal to capital X partial by partial X plus capital Y partial by partial Y plus Yx partial by partial Y prime. This is actually the value of the gamma 1 is equal to gamma plus Yx into partial by partial Y prime. Okay. Now students, if we define delta such that means the value of delta is actually the value of our given differential equation, that is equal to dy bar is equal to this one. So if we want to find the value of delta, this will become equal to dy by dx minus f of xy, means we will take dy by dx minus capital F, that is equal to 0, and this is the value of gamma. Now students, if we want to find the value of gamma 1 of delta, then we will write over here gamma 1 of delta, means we will apply gamma 1 on this value. So you can easily see that this is actually delta is equal to y prime minus capital F, that is equal to 0. Now if we take you can write capital X partial by partial X, means we want to take the partial derivative of this value with respect to x, then we will get minus fx, and this is equal to this one. In the similar way, capital Y as it is, and if we want to take the partial derivative of this value with respect to y, then we will get simply f of y plus yx as it is and partial by partial y prime. So if we take the derivative of delta with respect to y prime, then it will become equal to 1, so we will simply get yx. So all of these terms will become equal to this one, and that is equal to 0. Now students, if we compare equation number 2.84 and equation number 2.86, now this is equation number 2.86 and the equation number 2.84 is given by this one. Now if we will compare both of these values, then we will get to know that the value of capital Yx will become equal to this one, or you can say that here it is actually equal to capital X fx plus capital Y fy. So if you find the value of capital X fx is plus capital Y fy, then this is equal to capital Y of x. So this term will become equal to this one. Now students, we simply substitute the value of y prime is equal to f into gamma 1 of delta is equal to 0. So in this way we will get the least invariance condition, and we will set that gamma 1 of delta at delta is equal to 0, that is equal to 0, and it is a convenient way to write the invariance condition. Okay. Now students, the crux of this lecture is that in the previous lecture we have defined the least invariance condition in the extended form, that is given by this one. But students, now we have developed a technique that instead of writing this equation and finding the invariance, we will simply find the invariance of gamma 1 of delta, and we will set that at delta is equal to 0, that is equal to 0, and we will find the invariance of our given differential equation instead of the lengthy procedure. Okay. Now this is all about this lecture, and students, keep in mind, if we have a first order ordinary differential equation, then we will find gamma 1 of delta. But if we have the second order ordinary differential equation, then we will extend the operator, and we will find gamma 2 of delta for the second order equation, and in the similar way we will move toward the higher order. And student, this is all about this lecture. Thank you so much.